So what we were looking at was if x of t has a Laplace transform x of s, then e raised to minus at x of t will have a Laplace transform which is x of s plus a. So this is what we have seen, and the proof we have done with the case of one particular example of x of t, but we can do the proof in a very generic manner. So the first statement, the given statement is that Laplace transform of x of t is x of s. What does that mean? That means x of s is equal to integral t going from minus infinity to plus infinity x of t into e raised to minus st dt. Then what we need to show is basically the second part. So therefore Laplace transform of e raised to minus at x of t is equal to integral t going from minus infinity to plus infinity e raised to minus at x of t. So this is our new function multiplied with the old function multiplied with the e raised to minus at. So this into kernel into dt. Okay. So this one, if you now rearrange, what will happen is that this is equal to t going from minus infinity to plus infinity x of t into e raised to minus s plus a t dt. Okay, so I said you compare this with this. Okay, compare 1 with 2, and 1 is basically written as x of s. Okay, so therefore 2 can be written as, okay, so comparing 1 and 2, you can write this as x of s plus a, because here only difference between 1 and 2 is that here the kernel is e raised to minus st, now the kernel is e raised to minus s plus a into t. So if you get after integration x of s here, after integrating the first integral, if you get it as x of s, you should get here it as x of s plus a. Now if I mean a is negative, or you can say if Laplace transform of e raised to at into x of t has to be found, where a is positive, but here it is plus sign. Okay, so in a similar way you can say rearrange it. Only difference is going to be you can write a as minus of minus a, so then it will be s minus a. Okay, yes, so now any doubts? Somebody was trying to say something?
No, sir.
Yeah. Hello? Your voice is breaking. I'm not able to hear you well. Can you repeat? Can you try again? Okay. So maybe later we will take question at the end of the class. Okay, so this was what? This was a property basically. This is a property of Laplace transform which we have just now proved. Okay, so let's apply this property. Say.
Hello, sir.
Yes.
Am I audible now?
Yes, I am. You are audible now.
Sorry for sir, I got disconnected, sir.
Okay.
For a while. There was problem with my internet connection.
Okay, go ahead.
Sir, yes, sir. Could you explain me the back, sir, what you said, sir, about my question, sir, why u of t is not always considered?
Why your question is why u of t comes everywhere?
Yes, sir. Yes, sir.
Okay,
In
so
questions.
u of t is used to represent functions which are 0 for negative values of time. Okay, u of t is used to represent functions which are 0 for negative values of time, because u of t is 0 for negative values of time. For example, ramp function is basically t for t greater than 0, 0 for t less than 0. This is a ramp function, but you could write it as t u of t. So that's a convenient way to write, right? Similarly, we have seen parabolic function. Unit parabolic function is basically t square by 2 for t greater than 0 and 0 for t less than 0. We could write it as t square by 2 u of t.
Yes, sir.
Yeah. Does that satisfy you, or you want to ask more? So it's a convenient way of what I said is it's a convenient way of writing functions which are 0 for negative values of time, because that is implied in the expression for u of t. And why we are interested in functions which are 0 for negative values of time, that is a question that you can further ask. Do you want to ask that question?
Yes, sir.
Okay, so that is because one thing I earlier told you, that whenever you perform an experiment, okay, in the lab, we always start that at a particular point of time, which you will call as time t equal to 0. So before you start the experiment, the input was 0. So you can always set your reference of time as t equal to 0 whenever you switch on the the function generator, which will give you this kind of waveforms. Okay, a sine wave generator, it is there in the lab. So when you switch it on, it will begin to give you sine wave. But before switching it on, it doesn't give anything. So it is 0 output. The moment it is switched on, we have sine wave start coming. So that means if I draw the output of that sine wave generator, it will look like, depending upon the time that you switch on, it will look like, say I switch it on at say 1 second. So this is say 1 second. I switch it on the sine wave generator at 1 second, and then from then onwards it started giving me sine wave. So prior to that switching on, it is 0. Okay, now what I am trying to do is that, okay, so every signal is which we generate is like this. There is a particular time at which even if you are switching on a DC source, what you are doing is basically maybe it is 5 volt, so it will start giving you 5 volt from some point of time. Till then it is 0 volt. So the moment you switch on, it starts giving you plus 5 volt. Okay, so this is the on moment. Okay, here this is your on moment. Now, so all the practical signals are like this, whether it is a sine wave generator, whether it is a DC voltage, you switch it on at a particular point. At that particular point onwards, it will start giving the output. Till then it is giving you 0 output before you switch it on. So all practical instruments which generate signals are giving you like this, and therefore it is convenient to take the point at which you are switching on as time t equal to 0. Okay, So we can always shift the origin. We can redefine our origin like this and say that you switch it on at t equal to 0. So this is a new coordinate system where the origin is here at 1 second compared to the old coordinate system. According to the old coordinate system, maybe according to your watch it was 1 second you switched it on, but then I can always reset my watch such a way that the time I switch it on is taken as t equal to 0. Same thing here also. I can move the origin to a new location such that this point at which the waveform or the signal comes out is from t equal to 0. Okay, so this is the earlier one. I will call it as a t dash. So this was t dash and the new one is t. Okay, so the time according to the new coordinate system, t is basically t dash minus 1. That's it. So after you do all the calculation, if you want to go back to the old coordinate system, all you need to do is basically express everything in terms of t dash. You just give this substitution. Wherever t appears, you put t dash minus 1 and you will get the signal.
Yes, sir.
Okay. All right. So let's continue. So next problem, let's say problem number 9 is sine omega 0 t u of t. Okay, so find the Laplace transform. Find the Laplace transform. So Laplace transform of sine omega 0 t u of t is equal to integral t going from minus infinity to plus infinity sine omega 0 t into u of t into e raised to minus st, the kernel dt. And then again, if you substitute the value of u of t, integral will become from t equal to 0 to plus infinity. And sine omega 0 t, I will write it as e raised to j omega 0 t minus e raised to minus j omega 0 t divided by 2j into e raised to minus st dt. So I can write this further as integral t equal to 0 to plus infinity e raised to s minus of s minus j omega 0 t dt, then minus integral 0 to plus infinity e raised to minus s plus j omega 0 t. So you have written a sum of two integrals. So this is equal to 1 by 2j. 1 by 2j. So here, if I integrate this, so this is like the property that we saw earlier. If you know the Laplace transform of 1, that is u of t we know it is 1 by s. Now if I replace there with 1 by s minus j omega 0, so that will be the Laplace transform, or that will be this integral. and then minus, here it will be 1 by s plus j omega 0. Okay. Now what is the ROC here? Does the ROC change? So ROC for unit step is real part of s greater than 0. ROC originally it was a real part of s greater than 0. Then what we have done is basically s is replaced with s minus j omega and s plus j omega. Now ROC cannot change, right? Because these are imaginary part that we have introduced. Okay, we have not changed the real part. S minus j omega, only the imaginary part is changed. So imaginary part we are not interested to look at. The ROC is determined by the real part. So that will still be valid. Okay, real part of s greater than 0 is still valid. Okay, so this is equal to 1 by 2j into s plus j omega 0. I am taking the LCM, then minus s plus j omega 0 divided by s square plus omega square. Okay, so here s minus s cancel, j will cancel, then 2 omega 0. Okay, so there is j omega 0 plus j omega 0, so that is 2j. So 2j will cancel and we will get omega 0 by square plus omega square, where ROC is real part of s greater than 0. Okay, similarly you can do for the cosine. So let's say exercise number 10, that is Laplace transform of cos omega 0t u of t. So again, integral. So I am skipping few steps. I am putting it as 0 to infinity. Then I will replace cos omega 0t as e raised to j omega 0t plus e raised to minus j omega 0t by 2 into e raised to minus st dt. Okay, so this is equal to, I can put the 2 outside and write it as 0 to infinity e raised to minus s minus j omega 0 t dt plus integral t is equal to 0 to infinity e raised to minus s plus j omega 0 t dt is equal to half. So this one again, this one is also as before. This is 1 by s minus j omega 0, but with plus sign here instead of minus sign, and this is 1 by s plus j omega 0. So after simplification we have 1 by 2 into, so denominator is going to be s square plus omega square, and here we have s plus j omega 0 plus s minus j omega 0. So this cancel, and what we will get is s by s square plus omega square. ROC is again real part of s greater than 0. Okay, so that is cosine function. Now you can find out say 11. Find the Laplace transform of e raised to minus 80 cos omega 0t into u of t. So using the property, we can write it as s plus a by s plus a the whole square plus omega square. Now ROC will be what? In ROC also we have to replace s with s plus a. So therefore ROC will change now. That is, real part of s should be greater than minus a. So here I applied the property that I have shown in the first part of this class. Similarly, Laplace transform of e raised to minus at sine omega 0t into u of t is going to be omega 0 by s plus a the whole square plus minus. And again ROC is real part of s greater than minus a. So these are some of the typical cases that we will come across. So we have done a number of cases and then found out its corresponding Laplace transform. Now to find the inverse Laplace transform, you need to memorize this result. Okay, you need to memorize this result, and then you have to know what was the function whose Laplace transform is given in this. But sometimes the x of s, that is the Laplace transform, may not be in a standard form as one of this result is shown here. So you need to prepare the given x of s in a standard form, and then only you will be able to apply and find out what will be the original function. So one thing you have seen is that if there is a u of t in the expression, okay, if there is a u of t in the expression, then the Laplace transform will be, or the functions are basically right hand side function. That means for negative values of time they goes to 0, that is known, and so the ROC will be always real part of s greater than some particular value. Okay, if it is a left-handed function, that is, it is 0 for positive values of time, then ROC will be going to the left side of the s plane. So that is something that you can always keep in mind. Okay, and most of the practical cases we will have right-handed function, and the signals which are right-handed, that is 0 for negative values of time, are also called causal signals. Okay, so which I did not specify earlier, but that is a term that is usually used. So let me just put it here. Causal system and anticausal system I have told you, but now I am talking about causal signal. Okay, causal, non-causal and anticausal signals, not system. Okay, this is not specified earlier, but now I am giving you. So a signal is said to be causal if its value is 0 for negative values of time. Signal is said to be causal if its value is 0 for negative values of time. Okay, so for example, u of t, r of t, u of t minus 2, okay, etc. Now next is non-causal signal. A signal which is not causal is called non-causal signal. So that example, say u of t plus 2, u of minus t, etc. Number 3, anticausal. A signal is said to be anticausal if a signal is said to be anticausal if its value is 0 for positive values of time. Okay. So example of an anticausal signal, you can say u of minus t minus 1. Okay. So u of minus t minus 1, if you plot it, you will see that it is having non-zero value only for negative values of time. There is no value of positive time where the signal has non-zero values. Okay. So similarly, you can come up with so many different signals. Okay. For example, you have something like this. It is exponentially rising to the left, and this is also anticausal because it has non-zero value only for negative values of time. So that's basically what is anticausal. Whereas non-causal means it can have values for positive values of time, but at the same time it also has values for negative values of time. Causal means it only has value for positive values of time. Okay, so mostly practically we will come across causal signals because we can always shift our origin in such a way that the signal will have values starting from 0 and non-zero only for positive values of time.
Sir,
Yes.
does negative signals have any significance, sir?
Repeat the question.
Sir, does negative signals have any significance?
Negative signals.
Yes, sir. That are from negative axis.
Mainly,
Sir, the one above that you take the example, sir.
yeah, okay. So the one which I drawn here, you are talking about.
Yes, sir. What does it actually mean, sir?
It means it has these values as it is shown here. The signal takes these values for such and such time, and then after t equal to minus 1, its value is 0. So theoretically you can construct any kind of function. There is nothing that limits you, right? Thinking about a function, you can come up with your own function.
Yes, sir.
Yeah, so but practically it doesn't mean that all these possibilities exist or come in our practical experience, but theoretically you can construct everything. But practically what we come across is mostly can be thought of as a causal signal. So that is what I was telling.
Okay, sir.
Yeah. Any other questions?
Sir, then these signals we can consider it as opposite signals.
Opposite, you have to tell what do you mean by opposite.
Sir, that means in the reverse way.
The words need to be more clear. What do you mean?
Okay, so I think that's not a problem because with respect to t coordinate, we are plotting the graph here.
Yeah,
Yes, sir. For negative time axis, it won't be valid.
yeah. So I mean, as I said,
Including practical physics.
signal can have for any negative values from for minus infinity also you can have value for a signal theoretically, but physically does that make any sense? That is another question.
Yeah, yeah, yes, sir.
Yeah. All right. So now we are going to look at some of the ways to find out the inverse Laplace transform. So problems on inverse Laplace transform. Okay, so given x of s is equal to 7s minus 6 divided by s square minus s minus 6. Okay, so given the Laplace transform is given, find the inverse Laplace transform assuming the signal as a causal signal. Okay, so ROC is not given, but it is told that assume that the signal is a causal signal. So that is enough, because there may be two possibilities out of which you can choose one, because one of them will not be a causal, other will be causal. Now how do we do this? So if a problem is given like this, how do we do this? Okay, so you see that this given expression doesn't match with any of the expressions that we have derived. We have never come across any expression in this form, right? So we need to first of all prepare this given function into a standard form such that we can find the inverse by using the standard forms. Okay, so what is the standard form? So first of all, look at the roots of this polynomial. Okay, so the root of the polynomial in the denominator, if you look at, that is s square minus s minus 6. So if you find the roots, so what is the root for this? Can you tell me what is the root of this polynomial? Anybody? Can I write it as s minus 3 into s plus 2? Can I write this way? If I multiply, can I get this polynomial? Or okay, you know this formula, s is equal to minus b, okay, which is plus 1, plus or minus root of b square, which is 1, minus 4ac, that is 4 into 6 by 2, that is plus 1 plus or minus square root of 25 by 2, which is 1 plus or minus 5 by 2, that is 6 by 2, and minus 4 by 2, which is 3 and minus 2. So 3 and minus 2 are the roots, right? So the given function, therefore, x of s can be written as s minus 3 into S plus 2. Now what I do is I'm going to write it as A by S minus 3 plus B by S plus 2. I can do this. This is called partial fraction expansion. Have you come across this?
Yes, sir.
Okay, by the method of partial fraction expansion you can find out. So all I need to find out is the value of A and B. A and B are called the residues. A and B. That is a mathematical term. It's not important here in our purpose. Even if you forget what is A and B called, that's okay. But they are called residues. Now how to find A and B? So for that you multiply with S minus 3 into S plus 2 on both sides. So then you will get 7S minus 6 is equal to A into S plus 2 plus B into S minus 3. Okay. Now to find A, there is multiple ways. You can equate the coefficients. Okay. The coefficient of S, one method. You can choose your favorite method. Method 1 is equate the coefficients. Equate the coefficient of S. So what is the coefficient of S on the left? That is S, that is coefficient of S raised to 1 is 7. On the right hand side it is A plus B. So you get one equation. Now equate the coefficient of S raised to 0. S raised to 0 coefficient is minus 6. And on the right it is 2A minus 3B. This is equation 2. Now you can solve these two equations. So to solve you can either substitute B in the second equation. So from first equation you can say B is equal to 7 minus A, and therefore second equation become minus 6 is equal to 2A minus 3 into 7 minus A, which is equal to 2A minus 21 plus 3A, which is 5A minus 21. Okay, so therefore 5A is equal to 21 plus 6, 21 minus 6, so that is 21. If I take it to the other side, it will be 21 minus 6, so that is 50. So A is equal to 3. Now what is B? B is 7 minus A. 7 minus A, that is 4. So this is one method, but I prefer another method. If you prefer this one, you can do it this way. Method 2. Okay. Substitute values for S. What values you substitute? You basically substitute in such a way that one of the term will cancel. For example, if I want to remove the term involving B, I will substitute S is equal to 3. So I put S is equal to 3. So S minus 3 become 3 minus 3, 0. Gone. Now I know LHS is what? S is equal to 3. So 3 into 7, that is 21, minus 6, that is 15. So 15 is equal to A into then S plus 3. So that is 3 plus 2, which is 5. So A is equal to 15 by 5, that is 3. So that is the first substitution. Now second substitution, what will I do? S is equal to minus 2. So if I put s is equal to minus 2, so then it will be minus 14 minus 6 is equal to, so first term will go away, second term will be b into minus 2 minus 3, that is minus 5. So this is minus 20, so you can cancel, that is 5b, so b is equal to 20 by 5, this is equal to 4. So you can choose whatever method you like, but mostly I like the second method, cancelling this term and then equating LHS and RHS and finding out these values. Okay, there are certain cases maybe where the other method is preferable, so you can decide accordingly. It is not necessary that you have to substitute only these values. These values are convenient to be substituted. You can substitute s equal to 0 also, but then again you will get an equation in a and b, and then you have to solve two simultaneous equations. Okay, the point is find these residues, that is these coefficients. So we got a as 3, I think, a as 3 and b as 4. So therefore x of s you can now write, so x of s is equal to a is 3 by, so that is the denominator was s minus 3 and s plus 2. S minus 3 plus b was 4, s plus 2. So the given function, now we have prepared it in a standard form. It is the same x of s. There is no difference. Okay, whatever was the x of s which was given to us, it is the same expression. If you just cross multiply and do it, you will get back to whatever was the given expression. But it is in a convenient form to find out the Laplace inverse. So Laplace inverse of x of s is equal to Laplace inverse of 3 by s minus 3 plus Laplace inverse of 4 by s plus 2. So this is equal to, I can take this constant outside. This 3 is a constant. I can write it as 3 into Laplace inverse of 1 by s minus 3 plus then 4 into Laplace transform inverse of 1 by s plus 2. Okay, so I can write it. So this is 3 into, what is the Laplace inverse of this term? By now you should be able to tell this. So this has to be a right-handed signal. Okay. So in the problem, in the question, it was mentioned, assuming that it is a okay, so it is not really correct to say causal signal. So I will just modify this little bit. I would say right-handed signal. And you will see why. So right-handed signal means left side is 0 and right side it is non-zero. Okay, so there are two solutions for this, right? Because ROC is not given. So there are two solutions. One solution is right-handed and the other solution is left-handed. So let me pick out the right-handed solution, because that is mentioned in the question. So picking the right-handed signals. Okay, so that is e raised to 3t u plus 4 into e raised to minus 2t. So these are the functions. Okay, This is the inverse of the first function. If I take the Laplace transform of this function, I will get those results. Is it clear? So picking at the right-handed signals, both are right-handed signals, right? And they are causal also. Okay, so there's no issue here. you can say it is a causal signal also because it is fully right-handed. So I should not have changed the causal part. Okay, so I can say it is causal. So I can put in bracket. Okay. So that is how we find the inverse. Okay, let's do one more problem and we'll stop. Okay, so another question. Okay, so instead of doing a second problem, what if the question it was given it as a left-handed signal? What if it is given in the question that we have a left-handed signal? So for left-handed solution, that is basically anti-causal. So this is causal. So what will be our result? Anybody? Can you tell me? So 3 is a coefficient that will be there. Then how do we write the rest? E raised to 3t with a minus sign u of minus t. That will be the function. Plus 4 into this one will be minus e raised to minus 2t u of minus t. So that will be the left-handed solution. Okay. For negative values of time it has okay, but there is a catch here. T equal to 0 also it has value, so maybe it is not correct to say it is anti-causal, maybe non-causal you can say, non-causal solution. So causal and non-causal signal, if you assume you have two different solutions. Is it clear? Any doubts? So how did I get these expressions? From the table. Table means we have evaluated already certain functions, their Laplace transform. So by comparing it, we have written. For example, the result that I have used here is basically Laplace transform of e raised to minus at u of t is equal to 1 by s plus a. Okay, Laplace transform of e raised to bt u of t is 1 by s minus b. These are the result I have used. ROC is understood. ROC in this case is real part of s greater than minus a, and ROC in this particular case is real part of s greater than b. So this is the right-handed functions. Both of these are right-handed function, and for left-handed function we have used the result minus e raised to minus at u of minus t also gives us 1 by s plus a, but with a different RC. So here real part of s was less than minus a. And similarly, if it is positive coefficient, e raised to minus dt u of minus t, it's basically the same thing. Only thing is b is basically minus a, that's all. This also gives s minus b, but with ROC, this real part of s less than b. Okay, so I will stop here. If you have doubts, you can ask now, or maybe you can ask in the next class also.